And you can see the experience of person when they have a spinal cord injury, how many challenge person may have and how they should manage all of them. Therefore, whatever we are trying to do here is based on real experience that we hear from our colleague. And here in our institute, we have a division that we are using machine learning and other AI technique in our data to answer those questions that Sam raised here, that they are very important. At Praxis, we have a very good data that can help us to, for this spinal cord injury journey, we model each part and answer some of the questions we have. When person has a spinal cord injury, the first place they come to the hospital in acute center, and then they go to the rehab, then they go to the community, and also we are trying to help them to engage with each other and maximizing their participation in community. But for each of those stage of this journey, we have some specific outcome that we hope by prediction and optimizing the systems, we have a better answer for them. What we do here at Praxis, instead of working individually just by ourselves using machine learning on those topics that we are interested, we are hoping bringing clinician, surgeon, and people that they have a spinal cord injury. And as a team, we collaborate together and find best and important question and using machine learning to answer those questions and make some predictive model that they are helpful. But what we need for those kind of predictive model that we hope to get, one of the important things in machine learning that all of you know is the data. Fortunately, at Praxis, we have a national data. Everybody has a spinal cord injury in country. Usually, they send their data here in Vancouver. We are hub of that data. We have a largest database for spinal cord injury in our institute at Praxis, and therefore we are in a very good position of applying any of those machine learning that they need a large sample size. Also, we have opportunity to collaborate with other country, other research center that it gives us opportunity using international data. And other things we have at Praxis that we have a collaboration with so many surgeons and clinicians. They raise us important question that they think we should focus and find solution for them. Also, we have a team of machine learning people and statistics. And at the end of the day, when we make all of those things, we do a knowledge translation. We working to be sure that whatever we found, it passed to the community. People, they use. We don't just do those work for ourselves and just publish it and put it in our shelf. As Sam explained, when the person is in a hospital, the few important question comes to that person. One of them is after a spinal cord injury is survival. When I have a spinal cord injury, what is my chance for survival? And then when I have answer for that, then what is my chance for ambulation? How much chance I have for walking? Then usually a spinal cord injury is synergic with other things that people have, some comorbidity they have, and they make them a little bit more frail. And it comes to the frailty concept here. And then how those things, frailty and people characteristic, come to the health status and then quality of life. And at the end of the day, what will be healthcare utilization? What will be the cost for systems? We did several of those work that Sam put in his presentation here, such as predicting survival. We made a new risk score. We call it SCI risk score. But before than us, people use another risk score. They call it ISS, injury severity score. That was developed for all type of injury. But a spinal cord injury is different. I mean, you can use an index for any type of injury, but it will be great if you could have a specific score for this disease, then that will be more accurate. Also, we worked on how BMI can be related to the outcome. Is there any way we can improve the BMI system that we have? Because WHO has a BMI categorization, but it works for regular people. But when people have a specific health condition, we may adjust that categorization that WHO suggested. Also, ambulation, as I explained. We also made a new index using machine learning. We call it multi-morbidity index, MMI, that can predict several of those things that Sam explained. And at the end of the day, also we try to use machine learning to optimize our study design. One of the first applications, as I explained, is survival. We use our national data that we call the risk and recast and spinal cord injury registry that has more than 13,000 samples. And by using that, we make our predictive model. Now everybody has a spinal cord injury. We are able to have a prediction to see what is the chance of the survival. If somebody has a higher risk of mortality, we can detect in advance and put more energy on that person and help that person for survival. But why here we use machine learning? Why we don't run just one simple model, one regression model, such as logistic regression, and make a prediction? Here, in neurological data, usually relationship between variables are more complex, and we notice in our analysis when we apply some more sophisticated method from AI, such as neural network and those decision tree and those methodology, we may end up with better result. If you go to our paper that it's listed in our website, when you compare the result of our finding with traditional way, our performance of our model is 30% more than people they use now. Even in US, in Canada, and other centers, they use that model that work 30% less. And we apply those kind of methodology, give us some very good result. Another application was ambulation. We had a collaboration with other researchers from Ottawa University, and we make a predictive model. And this study was done first in the UK. We replicated in Canada. We noticed we can get same result. Therefore, now we have a good predictive model for ambulation. And in another study, we noticed it works for some people, not necessarily for all people. We are working to improve the result, but so far result looks very good. And the good things we did here is we didn't stop our work just publishing paper. We also focus on knowledge translation. Now we made the app on web. It's free. People can go and put their information. When somebody has a spinal cord injury, they can put their information, their age, sensory score, motor score, and other indexes they have. And this app will tell them that what is the probability of walking. But this app is unique, and you cannot find this app somewhere else. Although for over 100 years, we have a good document about the spinal cord injury and related health condition, but we didn't have such a things. Now this is available, and this is free for everybody wanted to use. And another application we did here for using machine learning is using concept of reality that was developed 2001 by Metniski and Rockwood in Dalhousie University as a multi-dimensional of loss of reserve, physiological reserve. We notice same concept can be used here, and we add complication comorbidity that a person has, and using that and make a good prediction that what will happen for their health outcome. And we, from the previous literature, we noticed if we could add something around 30 items, 25, 30 items together, it will give us a unique index that can have a wonderful prediction. And we did, and we noticed for those people in traumatic and non-traumatic spinal cord injury, if we add those variables that was listed here, we are able to make that index. And when we made the index, we noticed that it can help us for so many predictions. For example, if I consider a personal factor that a person has, such as age, gender, BMI, also severity of disease, injury, and environmental factors such as employment and living situation, those things, we can use our MMI, the index we made at the Praxis, and that can predict functional improvement, as Sam explained, that people can walk, can they move their hand, their leg, and how much they are independent from getting help from other people. And these things, if FIM and also MMI that we developed at Praxis, can predict other things also, such as physical health, mental health, and all of them together again can predict some other things, such as length of stay in hospital. How many times person comes to the hospital per month? And you can imagine when a person has a spinal cord injury, how much will be hard to come to the hospital. Every time you should get help from somebody else, drive you, come to the hospital. And here is the good things that when you manage those complication comorbidity by using this methodology that we suggested, uh, it is something that you can change it. In fact, we call it modifiable factor. You can change it. For some other things, for your age, for your severity, you cannot do anything. But for these items, you can. Therefore, it expected that you have a better quality of life. You come less hospital, stay less in hospital. It's good for person or have a better quality of life. Also, it's good for system to save the money. This is so many outcomes that we consider here, but we connected all together. We didn't want to have a one prediction, and I explained to you and go to the to the methodology. We wanted to say if we apply those AI and machine learning method, you can consider whole process. When person has a spinal cord injury, what will be the survival, what will be the chance of ambulation, what will be health status, physical health, mental health, what will be life satisfaction, and so many other things. And if you consider all of them, when a new patient comes to the system, you have a good uh, picture that how you can help them. And lastly, in our work, we also recently started making our large language model. You know, large language model was developed by other companies such as OpenAI or Google and other big tech company. They cover everything that they could find from the web and other resources. But if you ask a very difficult question or very, very specific question, they may not give you a very helpful answer. And we notice for our case, for a spinal cord injury, it might be good to um, train those models for your specific application. Therefore, you will get more accurate result that is more helpful for person. Also, you can work more on privacy of those information people share with those systems. It's all talk, but although I presented with Sam this work, but it is not just our work. As you can imagine, a big team of people helped us from our research department, our colleague, Dr. Benison Noonan, also Susan Humphrey from the data part, from the IT department, Federico, and so many other colleagues, they helped us that we could achieve this kind of